Today we will be talking about the change of base theorem. So it states for any positive real numbers x, a, and b, where a is not equal to 1 and b is not equal to 1, the following holds true. So we have, in this case, log base of a, x, and that is equal to log base b, x, divided by log base b of a. So the key thing here is that we have these log bases of b, and we can choose b as 10 or we could choose it as e. So you could have a log base of 10 or you could choose a log base of e, but you need to be consistent. So second, we have our x, it goes to the top, and then we have our a, and it goes to the bottom. So when plugging this into our calculator, we can choose base 10 or we can choose base e. If we choose base 10, we have log base 10 of x, and we want to go ahead and use the log x button in our calculator. Now if we choose the base e, we're going to have log base of e, x, and we want to go ahead and use the natural log of x button in our calculator. So looking at some of these examples, we want to go ahead and use this theorem to our advantage to convert these into decimals. So we want to go ahead and approximate to 4 decimal places for these logarithms. So log base of 4 and then 20. Let's go ahead and do the necessary actions on this. So let's pick log base of 10 first. Log base 10. Again, we need to be the same here. And then we have 20. It goes on top. And then our 4, it's going to go on the bottom here. So this is going to give us log base 10, 20, and divided by log base 10 of 4. So in other words, log base 10, if we go ahead and go back up here, in our calculator, that's going to be a log of 20 divided by a log of 4, just because we picked log base of 10. So log 20 divided by a log of 4 is going to get us a value of a 2.1610. We could do the same thing with the log base of e. So log base 420, using the change of base theorem, that would be the log base of e, log base e. And again, the 20 comes on top, and the 4 goes down to the bottom. So if we go back up, if we choose to go the log base of e approach, that's going to be the natural log of x button in our calculator. So this should give us natural log 20 and the natural log of 4. And this gives us the exact same value of a 2.1610. You can try it in your calculator if you would like, but just be consistent with which base you choose. So let's go ahead and look at one more example here. So in this one we have decimals. So log base of 2 and then 0.7. Let's do the log base of 10 first. Log base 10. So again, the number of 0.7 comes to the top here, and the number of 2 comes to the bottom here. So again, that's going to leave us with log of 0.7 and divided by a log of 2. And this should get us an approximate value of negative 0.5146. And we can do the exact same thing using the log base of e. So using the log base of e, we will get the log base of e, log base e. And additionally, the 0.7 comes up top, and the 2 comes down on the bottom. So this will give us, since we use log base e, natural log of 0.7 divided by, and then the natural log of 2, which is equal to a negative 0.5146.